We will now create a group of axes using the orthogonal axis generator. For this exercise, delete all existing axes that were created previously. Click on the orthogonal axis generator icon in the Modeling tab. As shown in the bottom status bar, pick the reference point, lower left, of the axis group. Place your mouse cursor on first major grid intersection, nearest to the global origin. Left-click to select this point. The orthogonal axis dialog will appear. The reference is the coordinate of the point you picked. This can be changed if desired. The insertion angle allows you to rotate the axis group. Angle is always measured horizontal, anti-clockwise direction. Direction when axis are horizontal axis, or closer to the horizontal. Axis label starts from bottom to top. Step equals 1 means the label starts from A, then B. Step equals 2 means, label starts from A, then jumps to C. Axis spacing is specified by multiplication sign. Alternatively, you can enter axis spacing separated by comma. Axis extension length is the additional extension of the axis length, from the nearest axis intersection point, used for better presentation. As for direction to axis, or axis closer to vertical, the axis label starts from left to right. Let us accept all the defaults and click OK. 4 numbers of horizontal and vertical axes of 3 meter spacing each will be created. Click on Save icon at the top in the Quick Axis toolbar. We will be using this model later. ProtaStructure allows you to load external DXF drawings and show them as ghost layers in the plan view. This greatly eases modeling and creation of members, by simply tracing over the reference drawing. You can snap to intersections and endpoint of CAD object. Further, each story can have a unique reference drawing. We recommend that DXF file should be simplified and prepared properly. Keep the file as small as possible, by deleting unnecessary objects, example hatching. Limit a single DXF file to maximum of 5 MB. Create separate DXF file for each unique story, helps to keep the file small. Please note that only line, arc, circle, polyline, LW, polyline and text entities will be shown. Block objects should be exploded. In this exercise, we will use a pre-prepared DXF file. A sample plan layout DXF file is created with a completed Quick Start Guide model. Start a new project with any template. Click on External Reference Drawing. Click Add, to select, and load the DXF file. The file will be converted into 2D drawing entities, inside ProtaStructure directly upon loading. However, it will not be visible, until the Active box is checked. Please check Active, it toggles the visibility of the external drawing. Unit. Please select the correct unit of the DXF file from the Unit column. The drawing will be scaled immediately. Story number. The imported file will be assigned to the active story initially. You can use the story number column to assign it to any other story. Only one drawing can be attached to a specific story. Use colors. If this field is checked, colors defined in the file will be used. If unchecked, a grayscale drawing is displayed. Opacity. This parameter controls the opacity of the colors. This field applies only if drawing colors are selected to be used. Scale factor. This factor scales the whole drawing. Import. This function is used to import axis and members directly. Offset value. The external drawing will, by default, be positioned with the nearest lower left drawing object, aligned with the global origin. Hence, the initial offset is at 0,0 from the global origin. This can be changed. Click the Move button. Pick 2 points on the plan view to move the external drawing. Dynamic input functionality, hit F2, can be used here as well. The offset value between the 2 picked points will be updated in offset column of the table. Import. You can use the same reference drawing to directly import axis and members such as beams and columns. This will be covered later. For now, click OK to go back to the modeling view. To model can now be done easily by tracing over the reference drawing. Let's model the axes by using the Axis tool by tracing over the axis of the DXF drawing. To measure distance between 2 points, right-click anyway on the screen, choose Measure. Then, pick 2 points. The dimension will be shown. Take note this dimension is temporary, and will disappear eventually after some time. You can also make use of the Offset Axis function. Model all the remaining axes using any method. After creating the axes, you can turn off the reference drawing by unchecking Active in the Story Reference dialog. DXF Import. Axes or grids and members can be imported from DXF. There are 3 options. Floor plan, example, a predefined structural floor plan. 3D physical model. 3D analytical model. 2D DXF floor plans can be easily imported and transformed into 3D modeling elements, as shown below. If you wish to import a drawing, which you also wish to use overlay against your model for coordination purpose, use the External Reference Drawing option. There is an icon for DXF import in the same dialog. DXF file should be prepared properly, following similar external reference drawing guidelines. DXF import module reads primitive CAD objects, and converts them to structural members as grids, columns, beam, shear walls, slabs, and piles. The below table shows supported CAD entities for 2D drawings. As stated in the table, the supported CAD entities are polyline and combination of line, circle or block. Each member must be included into a unique CAD layer. Example, column and shear wall must be separated into different layers. Remove all objects that is not part of the import. Example, hatching and title blocks. Program uses grids to form the nodes, derived from the grid intersections. For best results, grids should be predefined to locate every element. This means that ideally, there should be intersection of 2 grids within a column perimeter, and at the ends of each beam, or shear wall. There should be a grid along the beam and wall longitudinal axis. If grids do not exist, the program will try to automatically create them during the import. Overlapping or very closely placed grids must be avoided, to ensure the analytical model can be properly prepared. In this example, the left picture shows a messy grid system, which should be avoided. The right picture shows clean grid system, as recommended above. DXF import of slabs. Each slab must be drawn as polyline entity for 2D DXF import. The slab should be separated, and split at the beam edges, or the grid boundary for from frame system models. Defining the slab as a single piece is geometrically correct, but creates problems when creating the analytical model. Hence, it's not recommended. Slabs are very easy to create in ProtaStructure. Hence, you may find it more productive to create slabs in ProtaStructure than to import them. We will now try to use the DXF import function to import axes and members. There are 2 methods for DXF import. Firstly, you can use import DXF function import a 2D or 3D DXF drawing. Alternative, if you wish only to import a single floor using 2D DXF drawing, you can use external reference drawing function, which also have DXF import function within the dialog. If you are going to create a full model out of 2D floor plans, you'll need to create the stories first. You may also find it easier to use the external reference drawing import command for this. It helps to manage all drawings from a single interface and links to the DXF import interface. Go to external reference drawing. Then load the 2D DXF drawing. This can be the same file you wish to show the external reference drawing in the background. Then click DXF Import. Layers. Each member type should be defined on different layers in the DXF file. The layers in the file are scanned for keywords, to spot possible layers that may be used for entities, defining structural members. If layers for a specific member type are not recognized, please use the drop-down list to assign the layers manually. You can make multiple layer selection for each member type. At least one layer should be selected to enable that member type for import. Text layer is only necessary to relate grid labels with grids. You can use the Assign Layers button anytime to reset all layers, to the ones found by the program. You can reset the assigned layers using Reset Layer Assignments button. Connectivity tolerance. This tolerance helps ProtaStructure to correctly assign grids to shear walls, beams, and columns, even if nodes of the grids are outside the borders of those members' geometrical definition. Connectivity tolerance should be larger than the distance measured, from the beam or shear wall boundary, to the grid intersection. Min beam length. The length of a DXF line entity should be higher than this value to be eligible to form a beam. Maximum beam width. The import module checks all parallel lines against possible beam formation. Distance between two parallel lines should be less than this value to form a beam. Default beam height. Beam sections will be generated using the measured beam width and this value. Default slab thickness. This parameter can be used to assign the default thickness for the imported slabs. Default pile length. This parameter can be used to assign default length for the imported piles. For this exercise, we will import grids, columns and beams. We will now select the appropriate CAD layers. After selecting all layer and reviewing the parameters, click Import. The import will start, and a log will be shown stating which members are successfully imported, and also any problems and failures. Click Close to get back to the main model. With the basic grids and members imported, we can easily continue with the modeling process.